class 7 physics, and the topic is sound. And we will continue with what we've been studying so far, and today we'll discuss about the types of sounds. Okay, so there are two types of sounds. One are audible, the other are inaudible. And this one we are talking in regard to human beings. Okay, sounds which are audible to human beings and sounds which are inaudible to human beings. So audible means which we can hear, and inaudible means which we cannot hear. Okay, so we categorize it into two types. Human beings, if they can hear the sound, we call it audible sounds. And if the sounds are inaudible for human beings, then we call it inaudible. Okay, now audible means which we can hear, inaudible means which we cannot hear. Now sounds which have frequency between 20 Hz to 20,000 Hz. Okay, sounds which have frequency between 20 Hz to 20,000 Hz are audible sounds. That means we can hear sounds. Okay, we can hear sounds which have vibrations, that is 20 vibrations to 20,000 vibration. So any sound which produces 20 to 20,000 vibration, we can hear it. Okay, any sound. So sounds between 20 Hz to 20,000 Hz. You know what Hz is, isn't it? Hz is the unit of frequency. So 20 Hz to 20,000 Hz, we can hear those sounds. Okay, unless your ear is functioning well. So if you can hear that sound, those sounds are called audible sound. Now sounds which are below 20 Hz, like 18 Hz, 17 Hz, 10 Hz, it's not audible for human being. Okay, any normal human being cannot hear sounds unless and until you have supernatural powers, but that's different. Okay, sounds which are less than 20 Hz, we cannot hear those sounds. So we categorize it in inaudible sounds. Okay, and even sounds which are above 20,000 Hz, like 21,000, 22,000, we cannot hear those sounds. And those sounds are also referred as inaudible sounds. Okay, we are talking about human beings here. So audible, there are two types of sounds. One is audible, the other is inaudible. Sounds which we can hear are audible, which we cannot hear are inaudible. So example, sounds with frequency from 20 Hz to 20,000 Hz. And sounds with frequency less than 20 Hz or more than 20,000 Hz. Now, audible sound and ultrasound. Now see here, as I told you, human beings can hear a sound which produces frequency between 20 Hz to 20,000 Hz. Okay, and we can also write it as 20 kilohertz. It is called audio frequency range. That is between 20 Hz to 20,000 Hz. It is called audio frequency range. Many animals can hear sound waves with a wider range of frequency. Now we'll get to that. And now when we talk about inaudible sounds, there are two types of inaudible sounds. One are called ultrasound, other one is called infrasound. Okay, one is called ultrasound, the other is called infrasound. Ultrasound means sounds which produces a frequency above 20,000 Hz. That means produces a frequency more than 20,000 Hz. Okay, and sounds which produces frequency less than 20 Hz are called infrasound or infrasonic sounds. Okay, so sounds with a frequency too low for the human ear to hear are called infrasound, and sound waves with a frequency too high for the human ear are called ultrasound. Now infrasounds are sound below 20 Hz, like 18, 17, 14, 10, 9, 8, all this categorizes in infrasound, so less than 20 Hz. And ultrasound means which is more than 20,000 Hz. It can be 21,000 Hz, it can be 32,000 Hz, it can be anything above 20,000 Hz. So this is infrasound. So elephants can hear infrasounds. Human beings, they hear we can see adults and children. Okay, adults and children, that is human beings, they can hear between 20 Hz to 20,000 Hz. And bat is an example, okay, is an example which can hear sound above 20,000 Hz, that is ultrasound. So bats can hear ultrasound. Elephants can hear infrasound. Okay, but human beings can only hear audio frequency range, that means between 20 Hz to 20,000 Hz. Now, animals such as whales, elephants and hippopotamus use infrasound to communicate over distances. So they use this infrasound to communicate with each other. Okay, and animals like dogs, bats, birds and insects can hear ultrasound. That means they can hear frequency sounds which have more than 20,000 Hz. Okay, frequency. Now see, this is how a bat, or an aquatic animal like a whale or a submarine. So this is how they work. Okay. So what do? This is an example of reflection of sound, because sound also gets reflected, just like light. When light falls on a surface, on a smooth surface, what happens? It reflects back. You learned this in reflection of light, isn't it? You learned this in the chapter light. The same way, sound also gets reflected. So when it hits a wall or when it hits any object or any surface, what happens? It reflects back. And that we'll be discussing more in detail later when we'll be discussing about echo, reverberation, whatever is there. As of now, just understand that sound, when strikes a surface, it also reflects back. Okay, just like light. And it also follows the same laws of reflection of light. Okay, so now bat, it produces ultrasound. Okay, it produces a sound which has frequency more than 20 Hz. And then the sound as it travels, and if there's any object or any obstacle on the way, it will touch that surface and reflect back. Now when it reflects back, it reaches the ear of the bat, isn't it? So when it reaches the ear of the bat can make out from the sound itself, the reflected sound, whether it is an object, whether it is a prey, whether it is an obstacle. So then this is how it functions. This is how it works. Like a bat produces a sound, okay, which is an ultrasound. The sound, it travels, and as it travels, if there's any obstacle on the way of the sound touches that obstacle and reflects back. Now when it reflects back to the ear of the bat. Now with the reflected sound, the bat can identify whether it's a prey or whether it's an obstacle. Okay. The same way for the whale or any aquatic animals, like if there's fishes, if it's a prey, if it's food, or any other obstacle, if there's a stone, it can make it out from the reflected sound. And this one we'll discuss, sonar we'll be discussing later, okay, more in detail. Now, let's discuss more about infrasound waves. As we already said, infrasound waves are waves which produces frequency less than 20 Hz. So infrasound is sound that is lower in frequency than 20 Hz or cycles per second, the normal limit of human hearing. Now 5 organisms that use infrasounds are whales, elephants, rhinoceros, okapi, alligator. And these animals use infrasound to communicate over distances up to 100 of miles. So these are only examples, okay? And now the application of ultrasonic waves. You've heard about ultrasound a lot, isn't it? You might have heard about it in medical terms. The pregnant ladies or those who have any problem within, they use those ultrasound. The doctor advises them to use ultrasound to identify what is the problem, isn't it? The application of ultrasonic waves. First, ultrasonic flaw detection. That means if there is any crack, if there's any crack in a metal which cannot be seen with the naked eye, if there's any crack inside, to identify it, they use this flaw detection. They use this ultrasonics. Okay, they send the waves, and then if it comes back, from the sound only they can make it out. So ultrasonic flaw detection. Another one is cutting and matching of hard materials. Another one is ultrasonic soldering and welding. You must have seen it yourself, isn't it? Soldering and welding. Measurement of flow devices. Application in medicine. As I told you, we generally use in hospitals, isn't it? You might have heard those adults, or you might have experienced it yourself, that if you have any problems, no problem, sometimes doctors suggest you to go for an ultrasound. So it's also used in medical terms. Thermal effect, ultrasonic as means of communication. So infrasonic is also used in means of communication. The same way ultrasonic waves are also used in means of communications. That means to talk. Now this is how a bat finds its prey. Okay, a bat produces an ultrasonic sound. That means ultrasonic waves travel, and as it travels, and if it meets any prey or any obstacle on the way, after striking that, it reflects back. When it reflects back, the bat from the reflected sound can identify whether it's a prey or whether it's an obstacle, whether it's supposed to be, if there's any danger, or if it's the food that it has to hunt for. And this is an example of ultrasonic. This is a picture with ultrasonic welding and soldering. Okay, so this is how it looks like. Now, next one we're discussing about is reflection of sound. Now, see here, reflection of sound. So, how does it work? It's an experiment over here. Okay, this picture here refers to an experiment. So, this experiment can be done on the lab, or you can do it yourself. So what you need to do is you need to place wood over here, and you need to put you can roll a paper and keep it of the same size. Okay, but the angle has to be same. The angle, if it's this one is 30, this also has to be 30. If this is 50, this also has to be 50. That means between this and this, whatever is the angle here, the angle should also be the same here. Okay. Now you can put a source of sound here on one end, and you can put your ear on the other end. That means you can stand yourself on the other side. Now as you start, you just start the stopwatch. Now you know the sound of the watch, isn't it? The tick-tock sound. So as the tick-tock sound starts, okay, the sound travels from here, strikes the wooden board. Okay, that means strikes the wooden board and reflects. That means the sound which is produced over here, you can hear it from this end. You can hear it from this end. Okay. Though it's not directly connected, but what is happening over here is a source of the sound goes over here, and when it strikes the board, okay, when it strikes the board, it reflects back. And it reflects back and reaches the ear. So what is happening? This is the perfect example or an experiment to show that sound also reflects. That means reflection of sound. Okay, this is how sound reflects. Just like light. So as I told you earlier, reflection of sound is exactly the same way as reflection of light. And when we talk about reflection of light, we are talking about regular reflection. Okay, so the angle of incidence and the angle of reflection will be same. It means it follows the same laws of reflection of light. Okay, laws of reflection of light and laws of reflection of sound are same. The angle of incidence and the angle of reflection are same. Second, the incident ray, the incident sound, the reflected sound, and the normal, they all lie on the same plane. So, it just in the laws of reflection of light, instead of ray, you can just add sound. Okay, it is exactly the same. They follow the same laws. Now, moving on to more in detail. Now you can see reflection of sound. So this is how sound produces. You sing from here and it travels, and if there is any smooth surface, it reflects back. Okay, this is your reflected sound. Now reflection of sound is the phenomenon of sound wave bouncing back after striking a rigid, smooth surface. Okay, in a small room when a person speaks, the sound spreads in all directions. This sound can be heard by listener in two ways. One is directly, the other one is through reflection. It is difficult to distinguish between both sounds as it travels at high speed. These two sounds can be heard distinctly if they reach our ear at an interval of at least 0.1 second or 1/10 second. So, the room is empty right now. So what is happening is I can hear my own voice. Okay. It is because there are walls around, there are glasses, there are walls, there are smooth surfaces which reflects the sound. But the audibility, the clarity of the sound, would be possible only if the reflected sound comes back after 0.1 second. Okay, right now I am speaking and the voice, the sound, when it travels and it reaches the wall and comes back immediately, that is before 0.1 second, then I will not be able to hear the sound and not be able to understand the sound. Okay, not here, I am saying. Whatever I am saying, if it reflects back before 0.1 second, then I will not be able to understand the sound. Okay, I will not be able to make it whatever is being said. But if it comes back after 0.1 second, then it's quite clear. Okay, the clarity is always there. Like whatever word, if I say apple, and if it just comes back after 0.1 second, I can hear the reflected sound clearly. I will hear the word apple clearly. But if it comes back before 0.1 second, I will not be able to hear it. Okay, that is called persistence of hearing. That term is called persistence of hearing. The characteristic property of human ear due to which it cannot distinguish between two sounds if they reach the ear within an interval of 0.1 second is known as persistence of hearing. Okay, this is why people, those who talk very fast, and those who talk very fast, we don't understand their words. I talk very fast, so most of my friends says that you need to slow down, and I think I need to slow down here as well. So people who talk very fast, you don't understand them very well, isn't it? You don't understand their words very well. Problem, because it has to reach our ear. The second word has to reach our ear after what we hear. The first word, whatever word we hear, the second word has to reach our ear after 0.1 second. Okay, if it reaches before 0.1 second, the words are not clear. We don't understand the words. We do hear the words, but we don't understand it. But if it reaches after 0.1 second, then we can hear it quite clearly. So that is called persistence of hearing. That means in our ear, the sound remains for 0.1 second. Okay, so if you want to hear proper, it has to be like, the second word has to come after 0.1 second. And that is called persistence of hearing. And that is an example of reflection of sound. So we'll further continue this in the next class. And this much for today. Hope you guys are enjoying your stay at home. Hope to see you soon. Bye.